Clustering coefficient. The clustering coefficient measures how well a node's neighbors are connected to each other in a network. It quantifies the tendency of nodes to form tightly knit groups or the clusters. So here is the formula for clustering coefficient. Ci is equal to 2ei upon ki into ki minus 1, where ei represents the number of edges between the neighbors and ki represents the number of neighbors of a node. Now we will consider a simple example over here. We are supposed to find out the clustering coefficient of this given graph. So this is a graph given to you starting from node A. We have considered a node A. Firstly, write down which are the neighbors for node A. We have neighbors B and H. So see, we have written the neighbors of node A, B and H. You have two nodes passing from node A. Now you are supposed to find out the edges between the neighbors. Your neighbors are B and H. You have a single edge. So write down that edge over here, that is 1. Now using this clustering coefficient formula, we'll be finding out CA is equal to 2 into 1, that is single edge, upon 2 into 2 minus 1, that is nodes between the neighbors. It comes out to be 1. Then go for node B. Node B, you have neighbors as A, C and H. A, C and H, these are the three nodes. Now in between these neighbors, you are supposed to find out a edge. Is there any edge present between A, C and H? A, C and H. Yes, you have a edge in between A and H. Just a single edge, that is 1. So CB will be equal to 2 into edge, that is 1, upon number of nodes into number of nodes minus 1. This comes out to be 0.333. Similarly, find it for node C. For node C, you have neighbors as B, D, F and I. You have 4 nodes as the neighbors. Now find out edge in between these neighbors. Do you have edge in between B, D, I and F? B and D you don't have. B and F you don't have. D, I, no. Then you have an edge in between D and F itself, a single edge in between the neighbors. Accordingly, use the formula and find it out. It comes out to be 0.17. In the same way, find out the clustering coefficient for each and every node. For node D, you get the clustering coefficient as 0.67. For node E, you can get clustering coefficient as 1. For node F, you get it at 0.33. For node G, you get it as 0.33. For node H, again you get it as 0.33. And for node I, you get it as 0.33. In this way, you can find out the clustering coefficient for each and every node. For practice, you can consider few more graphs. These are the graphs given over here. See, in this graph, given graph, there are 7 nodes, but there is no single node passing through each and every neighbor. So for each and every node, you get the clustering coefficient as 0. Similarly, you can consider these two graphs. I have written the answers over here. You can try it for your practice. You can find out the clustering coefficient and check your answers.